All right, everybody, welcome to the Git seminar, something that I am sure will be the most useful part of your final project, regardless of what you're writing, what language you're writing it in, whether it's a desktop app or a website app. This is something that you can really leverage to make developing your final project a lot easier. So today, we have a very boss agenda. So we'll go through setting up and go through some basics before we get into some more advanced topics in version control. So before we get started, so what is Git? So if you look at their website, this is their official list of buzzwords of thing Git is. But basically, Git is a way of keeping track of versions of your software. So whether you have some version that represents some really cool feature, or your project partner has some version, Git allows you to kind of utilize things like file histories and branches to make developing software a much easier process. So instead of saving 100 backup copies of your website, we can use Git to really make this process a lot easier. So really, after reading all these bullet points and watching this, hopefully you'll agree with me that really Git is just awesome. So first thing you need to do to get started is install Git. If you're working on either Windows or a Mac, they're just these two really easy to use installers. Just double click them and then you have Git. If you're using the CS50 appliance, we've already installed it for you because we anticipated how awesome this would be. So just to make sure you have Git installed, if you open up a terminal or command line, if you just type in Git, you should get a message like this that basically shows a bunch of usage. If you get something like command not found, then you probably didn't install it right. So back up a step. So once you have Git installed, the first thing you probably want to do is get it set up for your environment. So as you make commits and things like this, which we'll see, you're going to have attached to it who made them. So the first thing you probably want to set up is setting your name. So right now, if you're opening the appliance, your name is set up to be John Harvard. But if you're collaborating with a partner and you want to try to find out who screwed something up, if everyone says John Harvard, then that's probably not the most helpful. So the first thing you might want to do is say git config, and this global says whenever I'm using any Git repository anywhere on my machine, I want my name to be, in this case, my name. So just like you have a name, you're also going to have an email. Notice you don't need quotes around this email because it's only one word. So before you do anything, you can type this in any directory in your appliance, and this will basically set up your own Git environment so that it's you. So now in order to start using Git, we're going to create what's called a repository. And a repository is basically a container for all of your code that contains things like file histories and different versions of files. And so to create a new Git repository, all we're going to do is we're going to go into the folder that contains all of our source code, and we're just going to say git init. And this is going to create a new Git repository, which basically is just one little folder that says .git that contains all of your file histories. So let's do just that. So here I'm going to make a new directory. I'm just going to call it repo. And this is the directory in which I'm going to store all of my source code. So if we go into repo, I'm just going to create a couple files. So let's just create a home page for myself, so like a .index.php. And this will just say something like git rocks, which it does. So there's one file. Now let's just create another one since I have a really extensive final project, and say something like, so there we go. So here's my very extensive final project. It just has two files right now. So now I can type git init. This is going to say initialized an empty Git repository in, and this is the folder that I'm currently sitting in. So now if I list out all the files inside of this directory with ls-la, you'll see I have this new folder, .git. And if I go into that, this is basically what Git is using internally to keep track of all my files. And we'll see more about what's actually contained in here later. But now we basically have a Git repository, and I can use all of these Git features to keep track of my source code. So as I mentioned before, one of Git's major features is keeping track of file versions. So the way that we can basically save a current version of our file is with something that's called a commit. Now, a commit is basically just a snapshot of what your code looks like at a certain point in time. So in order to make a commit, we first want to check out what our repository looks like right now. So if I run something like git status, that's going to tell me, well, do you have any new files? Have you changed any files that you need to commit? And so to do that, just really simply, I can just say git status. And so you'll notice that I just created this repository, and I haven't made any commit yet. So what this says is I have two untracked files, or files that I have not added to my repository yet, because I haven't said anything other than create an empty repo. So I have those two pages I created, index.php and page.php. So now let's say I want to actually add them to my repository, and I want to start tracking the versions of these files. So the command to do that is going to be git add. And this is going to take an argument that's just what file do you want to start tracking. So if I say git add index.php, I'm going to add that to my Git repository. Now it's going to be really tedious if I want to keep typing git add and then every single file name. So there's just this handy flag git add all. And this is going to add every single file, whether it be contained in a subfolder or at the top level. It's going to add everything to the commit that's about to be ready to go. So now if I want to actually commit my files, I'm just going to say git commit. And this is going to create a snapshot of my files as they are right now and save them so I can access them whenever I want later. So associated with the commit is something called a commit message. And the commit message basically says, what did I do inside of this commit? Why is this snapshot different than my previous snapshot? Did I do something like add a new feature? Did I fix a bug? And this is usually just a short message. So some example commit messages. So this is from the CS50Q, which we're using Git to track. So something like, I've made the performance a little better. So just tweak that. That's a good commit message. Or added a new feature like attendance logging, because we keep track of what staff show up on what day. So that's just a small little commit message. If you're bored or would like to procrastinate, I would highly recommend commit logs from last night, which is a good place for 3 a.m. commit messages, which tend to be a little less descriptive than normal. So because this kind of two-step process, this git add all, git commit, and then opening up a text editor and typing something is kind of tedious, there's this little shortcut. If you say git commit, this -a, that's going to say before you do anything, I want you to add all the files to the commit, which is just kind of removes that extra step we had before. Now if I say -m, this allows me to just specify my commit message right here, so without having to open up a text editor and save some file. So let's take a look at making some commits in our repository. So here I said, well, I don't have any track files yet, so let's actually add them. So if I say git add all, and now say git status, and say, OK, well, now you're about to commit these 2 new things. You have a new file called index and a new file called page. And they're added to what's called the index, or the staging area. And this is basically what files are about to be committed. So when I say git add all, I've added these 2 files to the index. That being, they're about to be committed as soon as I type git commit. So let's do that. If I say git commit, we're going to open up a text editor. In this case, I'm using Vim. And I can type in my first commit message. So if I just say something like first commit, and I save and quit this, then I have just made my first commit. And here we have a little details of what just happened to this commit. In this case, I have 2 new files, index.php and page.php. Make sense? All right. So now, if I want to look at a history of all of my commits, I can use what's called git log. And this will basically spit out a history of everything that I've done inside of this repository. So when I say git log, what I'm basically going to get back is something like this, where each of these blue blocks represents a single commit. And every commit, you'll see, has a parent associated with it. What commit was previous to this one? It's very linear history. So associated with each of these blocks is what's called a commit ID. So this is basically a long hash of what you did in this commit. So each commit ID is going to be unique, even if the commits are effectively the same. So we also have this special commit ID called the head. And the head is always the most recent commit. So if I started off at the top and made a couple of commits, I've generated 3 new commit IDs, or ways of accessing those commits with the single string. And the last one I can refer to in all of my Git commands as just capital head. So now let's make another commit inside of our repo here. So I'm going to add a new file. So I'm just going to create something like page2.php, and this will just say something simple. Now I'm going to change index.php instead of creating a new file. So I'm just going to say something like I made a change. And now I'm going to make another commit. So rather than saying git add all and git commit, I'm just going to say git commit am, and here's another commit. So now here my stats are a little different now. I've changed one file, index.php, and I've created some new file. So now if I type git log, here's my commit history. So the first one, again, here's that author. So when I said git config user.name, this is where this is going to show up. So here's my first commit. It has a special commit ID. And there's my commit message. And so now I have another one on top of it. And so these are displayed in descending order. So most recent is going to be displayed first. So now that's nice if I have a history of all my commits. But now what if I want to actually see what happened in each of those commits? So to do that, I'm going to say git show. So if I just type in git show at the command line, it's going to show me what I did in my most recent commit. If instead of just looking at my most recent, I want to look at a specific commit, well, then I can just say git show, and then I can type in that hash or that commit ID. Now, typing that whole long thing in is going to be pretty annoying, so I can actually just use the first 5 characters. And most of the time, that's going to be unique enough for Git to figure out which commit you mean. So if I go back into my repo and I just type in git show, this is going to show me what I did in this last commit. So notice here that in the file index.php, I changed this line git rocks. I removed that and replaced it with this new line I made a change. Make sense? All right. So that is some really basic Git commands. So now we've seen how to create a repo, check the status, we can add files, and then we can make commits and see what we did in each commit and check out all of our history. Any questions so far? Excellent. So now we can get into some cool new stuff. So a branch is something that we haven't really seen yet while we've been developing software, right? If we have some new idea, well, we're just going to kind of edit the file and probably make a backup beforehand. If it doesn't work, then replace this version with our backup. But that's really, really inefficient, right? So what branches allow us to do is kind of take this linear development process of just changing this one file and make it nonlinear. So basically have 2 versions of the file where we can access either version at any point in time. So if I'm working on my final project and I just come up with some really cool new crazy idea, and I have no idea if it's going to work yet, but I want to try it without having to blow away all of my other changes, I can create a new branch. And any changes I make on that branch are not going to affect the original version of my file. So if it turns out that this idea didn't work, well, I can just delete this branch, and I've just lost all of those changes without having to ever affect my original file. So this crazy idea that didn't work doesn't mean I have to go back and fix my original version of the file. That was nice. If it turns out that this change did work out pretty well, then I can merge in the branch. I can say that now I want this crazy idea, I want this to be part of my actual final project. So in order to create a new branch, I can say git branch and then the name of my branch. So in this case, I'm just testing out a new feature, so I'm going to call this branch test. And throughout this, we're going to refer to this branch as test. So after I create this branch, I now have two histories right now. I have 2 versions of my final project. My current version, which lives on a branch called master, and this new version that lives on a branch called test. So if I want to switch to this new version, all I'm going to say is git checkout test. And now all of my files are going to switch to this version that's kind of experimental, or whatever it is with it we're doing. So let's say that I have a history that looks like this. So this is kind of the linear history we've seen. If I create a branch, I can take that history and make it look something like this. So now I can make commits on master, or the kind of stable version, or the version that I'm working with, and I can make commits on test. And these 2 commits aren't going to affect each other at all, because I've effectively created multiple versions of the same file. So let's do just that. So let's just create another commit. So let's just say git add all, git commit m before I merge, so that we know, or before I branch, I should say. So now let's say git branch test. So now, if I execute git branch, I'm going to get back a list of all the branches that I have. So now, you'll see I have this branch master, which is kind of the default branch. And the little asterisk next to it says that's the current branch that I'm on. So now if I want to switch to test, I'm going to say git checkout test. And so now if I say git branch again, you notice that I've now switched to this test branch. So now let's implement my crazy idea. So let's create some new file. I'll just call it crazy.php. And so we'll save this. So now let's commit this. So git add all, git commit m. And so now I've just made some new commit on this branch, right? Everyone follow what I just did? I made some new file, I added it to the commit, and then I made the commit with that message. And so now let's take a look at all the files I have. So there's my crazy.php, and if I run a git log, you can see all of the commits. So I just made that commit there, and then I also have all the commits from my original branch that I branched off of. So now let's switch back to the master branch. So to do that, instead of git checkout test, I'm going to say git checkout master. So now I want to switch back to this default branch that I started on. So when I say git checkout master, now if I do an ls, my crazy idea is not there, right? Because I have two versions of my project now. And even though I just changed this test branch, it's my original branch, this master branch, is totally unaffected. So even if I do a git log, I don't see that. The last commit I see is the one that I made before I made this branch. Make sense? So super, super handy. So now I've basically pulled in all of these changes in my experimental branch, and now they're inside of my stable branch, which is really, really cool. So now I'm totally done with this branch. I don't need to use it anymore, so I can just delete it. And to do that, I'm going to say git branch and then -d for delete, which makes sense, and then just the name of the branch that I want to kill. So if I go back into my repo and I say git branch d test, I've just deleted this branch test. So if I say git branch again, it's gone. And that's OK that we deleted it because we've just taken all those commits and we've merged them into master. So it's OK that we just deleted that. So now you'll notice that when we said git merge, that git made a new commit for us. And that commit represented the point at which we merged those two files. So just to remind you of when we say git log, you'll notice that I never made a commit that said merge branch test. I never typed that in as my commit message. This is something that git did for me. And this is the commit that represents the point at which I merged these two branches. So that's why our diagram, we had two arrows going to the same commit block. Now, what if you don't want to do that, right? Because that can kind of create a lot of unnecessary commits, right? If you're branching and merging all the time, then for every branch, you're going to create this whole new commit, which you may or may not care about. So if we don't want to do that and kind of have a more linear history, then instead of saying git merge, we can say git rebase. So here's the difference. So we created this new branch test, and again, we have commits on both sides. So now, instead of merging them and creating a new commit, if we say git rebase, we've kind of preserved the linearity of our history here. So what git rebase is going to do is basically rewind back to the point at which you branched, and then replay all of your changes on top of it. So we're not creating some new commit. We're literally just replaying all of our changes onto the point before we rebased. So let's take a look at what that looks like. So if I say git log -- graph, what this is going to do is give me this nice, cool ASCII kind of picture of what our development process looked like. So you'll see here that when I said third commit, that I'm still in the master branch. But now this commit so crazy up in here, remember, was made on the branch test. So you can see that we've kind of branched off from this default branch. So that's why we have that little other line. So now, when I said merge branch test, we have these two branches coming together to this single commit. So this is what happens when we do a merge. Now let's instead look at what happens when we do a rebase. So I've actually taken the liberty of just creating this other repo where I basically recreated all of the steps. So here's my git log. So right now I'm on master. So I can do git checkout test. And again, I've made the same commit. So this is basically just a copy of what our repo looked like before I merged it in. So now let's go back to master, say git checkout master. And now instead of saying git merge test, let's say git rebase test. So I hit enter, and it's doing just what I said. We're going to rewind, and we're going to replay all the changes that we've made. So now if I say git log graph, you'll notice that there's no branch. I've effectively linearized my history. So we didn't create this unnecessary merge commit anymore. You notice the last commit is just third commit on master, and we've just kind of inserted this commit I made on my branch inside of my linear history. So we don't have that wasteful merge commit. And depending on your style, this could be a little better to look at if you're branching and merging all the time. So unfortunately, when we have things like merging and rebasing, Git can sometimes run into conflicts. So maybe there's a point at which you changed one file in one branch, and you changed that same file in another branch, and you kind of changed the same area of the file. So when Git tries to merge them together, it's not sure what you want to do, because you have two really recent versions of the same file, and when you try to merge them together, Git's going to say, well, I don't know which one you want. So instead of trying to fix that for you, I'm going to let you fix it yourself. So let's say I have this one file. So this top version is on one branch, and this bottom version is on another branch. And so you can see here that I've kind of made an incompatible change. Right? There's kind of no way of merging these two things together, because you'd have to replace one with the other. So if I tried to hypothetically make a merge with this conflict where Git didn't know what to do, what Git is going to do is it's going to tell me, you have a conflict. And what it's going to do is change the file with the conflict and let me know exactly where my conflict is. So this first line is going to be the version that's on head, which, remember, head is the most recent commit. So in this case, it'd be the head of the branch that I'm merging into. And it's going to list out what this file is. So then we're going to have a line of equal sign. And below that, it's going to list the other version of this line. And so this is the version from the branch that we were trying to merge in. So when I say git status, Git is actually going to tell me, here are all the files that you have a merge conflict in. Again, these happen kind of rarely, but when they do, this is what you're going to need to do. You can basically edit this file yourself. You're going to want to delete the equal sign, delete those arrows, and just put whatever line you actually wanted. So now I can just add and commit that change, and I've resolved this conflict myself that Git wasn't able to do. So any questions so far, now that we've covered branching and checkout? Yep?
With the diff, or the basically trying to sort out conflicts, I guess at some point do you always do it from the command line? Let's say you've added a block of codes in one file but not in the other, and they're not totally compatible. What's the process of trying to merge the two?
So what's the process of actually trying to resolve these conflicts? So if in the case of just a few conflicts, that's what you could do. You could just say, well, Git said there's a conflict in this file. I'm just going to look through it and resolve the conflict. But if you have a lot of conflicts, that's kind of annoying. And there actually exist a few really good tools for kind of walking you through all of the conflicts and allowing you to graphically say, I want this one by clicking on this one, and I want this one. So if you look at something like Meld or OpenDiff or VimDiff, if you just run those from the command line, it'll open up a graphical program and allow you to kind of walk through all of your commits. And so if you run from the command line git merge tool, where merge tool is one word, that'll open up your default diff viewer, which you can change just with git config global. And it'll just walk you through all the conflicts in your current repository, and then take care of adding them all and committing them and fixing them for you. So that command was... I'm sure there is, actually. So if I just say git merge tool, no files need merging yet, but we'll see in the case that they do in just a moment. But I forget what it is called, but there is definitely an Emacs-based diff tool. Yeah. Yep.
So earlier you had index.php change in both branches, or when you merged them, there was no conflicts, right?
Exactly. So in this case, we didn't have a conflict because most of the time Git is going to be really smart. What Git's going to say is, well, this commit is after this other one, so you probably want this later version. So your commits are fairly rare, and usually Git's going to be smart about which version you really want. But this can sometimes come up, and it will be really confusing if you haven't seen it before.
So like right now, your index.php is only the later version?
Yeah, so this is just the version from before. So if I go back into repo this time. So we don't have any more branches. And this is my version, my latest version of index.php. Yep?
Just a few short things. All the changes that you made were like adding things, I think. So if you deleted something in your branch test, for example, and then you went to merge test into master, would it then go ahead and do the delete that you made in test?
Exactly. So it just like any change is kind of the same. If I made some insertions or I made some deletions, then when I merge, Git is going to try to be smart about it. But in the case of deletion, it's probably going to be a little more conservative and say, did you actually want to delete this? I'm going to create some conflict you have to resolve yourself. So it's totally on a kind of a case-by-case basis of what exactly did you do. But Git is going to try to say, this is what you want based on your commit history. but it's never, it's very rarely going to actually kill you. If it doesn't know what to do, even a little bit, it's going to ask you to resolve it yourself.
Okay, and one other thing, when you show the git log graph, I think it didn't show your first 2 commits on there.
Oh, sure. So if I actually go back to git log graph, this is actually scrollable. So if I hit down, I can actually scroll down. And just like a man page, to get out of here, I'm going to hit Q. Yep.
Let's say you you did an initial commit, you added 2 files, you did another add all, and then several commits later, does Git, I know with the alternative version control program that I have used in the past, once you've added a file, the program will always follow those files. Do I have to, does it remember what I've added 2 commits back, or do I have to re-add?
So before you make any, so after you make a commit, you've basically cleared the staging area. So this says everything that's about to be committed, well, I've just committed it. So I'm going to kind of remove that from the index. So before you make a commit, Git is only going to commit what's in the index. So in order to actually commit a file, you need to add it to the index via git add all or git commit am, and then commit that. So if you just say git commit, that second commit isn't going to do anything because you haven't added anything to the commit yet. Yeah?
But I've created file A and file B, and I've added them.
Mm-hmm.
I've made commit number 3. And then, let's say I change file B. I make commit number 4. With Mercurial knows it's already following file B and will automatically add the changes. Do I actually have to remind Git to add file B again?
Yes. So so like I said, so before you can make a commit, you have to explicitly add it, even if you've previously added it. So that's why this git commit-a.m is a really common way of making commits. So there could be a case in which you change a file, but you don't actually want to commit it. So in that case, you wouldn't add it to the staging area. Where if it automatically added it to the staging area, you would kind of commit everything, where you might not necessarily want to do that. So most of the time you do. You want to create a complete snapshot. But in the case that you don't actually want to commit a change, then you just wouldn't add it to the index. But the most common thing is add everything and then commit that, where you actually have to explicitly add everything to a commit, just so it's really clear what's actually being committed.
To each single commit always?
Yes, so to each and every commit, you want to add everything you want inside of that commit. Yeah?
I was going to ask if you can remove stuff from the staging area.
Oh, sure. So can you remove stuff? So when you do a git status, it'll actually tell you in this little comment here. You can say git rm -- cached, and that's going to remove something that you've already added. It'll just remove it from the staging area. So Git actually tells you how to do that nicely enough. So let's move on. Now that we know how to do things like branching and experimental features. So now inevitably, while we're developing software, we're going to make a mistake. And let's say we've made a few commits and we've realized that, OK, well, this is in the completely wrong direction. And now if we created a branch, we can just say, OK, well, I'm going to switch back and delete the branch and forget about it. But let's say we didn't make a branch. We want to roll back and go back in time and go back to the file as it was in some certain commit. So if I say git revert and then some commit number, what I'm going to do is I'm going to take my current status and I'm going to make it the status as it was in a certain commit. So let's say my history looks like this. My head is currently pointing at this commit 46147. So now if I say, well, I've actually messed up. This commit introduced a bug into my system. So I want to roll back to the commit before this. I want to take my files and roll back to this commit b43b0. So to do that, all I'm going to say is git revert b43b0. And so now I've created a new commit, again with the new commit ID, in this case 42b44. And what this commit does is it's rolled back all the changes, or it's basically undoes everything that I've done between b43b0 and this was previously my head. So let's take a look at what I mean by that. So let's jump back to our repo. And just to remind ourselves of where we are, if we ls, here are all my files. And I'm currently just on the master branch. I haven't done anything. And so now let's make a change. So let's say I make this change, and this is a good idea. So this is something that I would have no problem rolling back to. So if I git commit am, so you notice I had to explicitly add this change, even though we've already committed index in the past. With this -a, I'm actually adding it to this commit. And so now let's kind of make a mistake. So that was a good idea. Well, this is a bad idea. So now, again, let's commit this. And so this, we've decided, is a bad idea. So if I look at my git log here, this is what it looked like. Here are the new 2 commits I introduced. Now let's say that I want to roll back to this commit where I had a good idea. So if I actually look at my index.php file, it looks like this. We're currently at a bad idea. So now let's say git revert, and I want this one. So I'm just going to double click it, copy paste, and I'm going to revert to this change. Now what did we just run into here? This is a conflict. So Git decided, well, you have these 2 versions, and I can't really decide which one you want. So I want you to resolve this yourself. So now if we do a git status, you can see the unmerged file is index.php. So in order to resolve this conflict, all you need to do is look at index.php and fix it. So let's open up index.php, and we have, like we saw, these 2 things. So up at the top, we have the version. That's our current version, which was a bad idea. And now we're looking at the version that we had before. So let's just say we want to get rid of this and rid of this. And so now we can explicitly say git add index.php. And now when we say git commit, there's our revert. And we are good to go. So now we've basically just replayed these changes that we made before, and now we've added them into our current version. So we've basically undone those changes. OK. So now instead of undoing all of the changes, let's say that we want to just pull down a file in a previous commit. So let's say that we're working, we've said something like git add index.php, and we made some more changes. But now we want to kind of undo what we just did. We want to roll back to what we had before, after we added, but before we made those changes. So if I say git checkout -- and then my file name, it's going to take this file index.php and replace it with the version in the index. So this is one reason why the index is kind of handy. It's a little bit like a checkpoint. So these are the files that are about to be committed. So at any point, not only can I roll back to a commit, I can kind of roll back to my checkpoint or before or what I was about to commit. So if instead I want to replace this version of the file with a specific commit, I can say git checkout, and then instead of -- the actual commit hash. And that's going to replace the current version with the version in some given commit. So let's do that. So let's say, so I'm just going to add this. So add this. So I'm going to say git add -- all. So now if I show git status, then we've modified index.php. And so now let's say I'm going to do something else, and I kind of messed up, right? So now I want to roll back to this version that's in the index. So if I say git checkout -- index.php, open it back up again, this is the version that's currently inside of the index. So instead of that, let's try to roll this back to a specific commit. So let's say git log, and let's just roll back to, I don't know, this version maybe. And so let's say git checkout, the commit hash, index.php, open it back up, and I'm back to the point that I was after the merge. Make sense? Yep.
So say git commit -- index.php, and rolls back to the most recent change.
So when I say git checkout -- index.php, this is going to roll back to the version inside of the index. If I want to roll back to the most recent commit, I would just say git checkout head in all capital letters, index.php. And that's going to pull that file back to my most recent commit, where this -- is kind of before what is going to be committed if I were to commit right now.
Oh, okay, so if you changed it and then you didn't commit it.
Right. So if I had already added it, then I changed it again, and I realized, oh, I want to go back to where it was before I added it, or when I added it, then that I would say dash dash. Else I would give a specific commit. So then, that can be a little dicey, and a lot of times you can find yourself kind of lost in Git things. Question first?
I was confused how that was different than git revert. What you just did.
So git revert actually created a new commit. What git checkout does is it's literally just going to replace the file with what it was before. So it's not going to make a new commit for you. And git checkout is kind of operating on a file-by-file basis in this case. So because we said just this file, we're just pulling down that file. Where revert is saying, I want all the changes you made in a specific commit and to undo them, essentially. Yeah?
Can you do git revert and do it file specific?
So can you do git revert on a file-specific basis? So git checkout kind of makes a little more sense with that, right? What you would do is you would check out a file, and then you create a new commit, and that's kind of your revert commit for that single file. But what you can also do is actually check out an entire commit, which we'll see next. But before that, if while you're doing all these cool git commands, you find yourself kind of lost and you might have screwed something up, at any point you can always say git reset -- hard and specify a commit, and that's going to blow away everything you have and replace it with a certain commit. So if, over here, what I've done is I've kind of made some edits and I don't know where I am anymore, and I want to get back to where I was, if I say git reset -- hard head, it's going to say everything you've done, I'm going to get rid of it, and I'm going to stick you back at this commit head, which, if you look at the log, happens to correspond with this commit oops. So this is really, really handy. So also handy is we actually have a history of everything. Question?
Git reset hard is irreversible.
So that's actually a perfect segue. So if I do something like git reset hard, is that effectively irreversible? No. And that's because Git is actually going to log absolutely everything you do. So if I type in, instead of git log, git ref log, this is going to give me a log of everything I did. So git log is only going to give me a history of all these commits. But if I type something like git ref log, this is going to give me a little something different. So this is going to give me a history of everything I've done, not necessarily just a history of all these commits. So you'll see here that when I ran a reset, that I can actually undo where I was before the reset. Make sense? So this is kind of everything, where the message next to it is what I just did. So let's that head at 6, this is where I actually did this checkout. So if I wanted to go back to the state where I was when I did the checkout, I could use these hashes instead of the actual commit hashes. So nothing is really irreversible in Git, because when I say git ref log, I'm going to get a history of everything I did, so I can undo virtually anything. So another cool feature of Git is this thing called git bisect. And what git bisect allows you to do is to do a binary search over all of your commits. Now that sounds kind of weird, but this is really helpful when you're trying to find something like a bug. So if I'm developing along and I realize, a couple days later that, oh, there's some bug in my system now, and I don't know when I introduced that bug. Luckily, I have this long history of commits. So I could do something like check out each commit or something, or I can use bisect to have Git basically do that for me. So it's going to say, you're going to tell it which commit definitely has the bug, and which commit doesn't have the bug. And then when I say git bisect, it's going to do a checkout of each commit in a binary search fashion, so you can really quickly find the bug. So let's see what that looks like. So let's say that we definitely know there's no bug in my first commit. So that's going to be here. So let's say git bisect good. So that's a good commit. But my bad commit starts at head. So right now there's a bug in my system, so this head commit is bad. Git bisect bad. So now I'm going to say git bisect start to start this binary search, and Git even offers to do that for me. So now when I say yes, maybe not. So there we go. So now it's saying bisecting. I have 3 revisions left to check. So currently, I'm at this revision, this commit that corresponds to so crazy up in here. And so this is essentially the middle of my history, because the binary start is starting at the middle of my history. So if I look at all my files, I'm at the state where I was inside of the middle of my history. So let's say that I can test my website and I can find out if the bug is still here. So if the bug is still here, I'm going to say, well, I want you to keep looking because we haven't found the commit in which I introduced the bug. So I'm going to say, this is still bad. It's going to say, OK, well, next step in my binary search is this commit. So then I can open up my file again, and you'll notice it's going to be different. Well, that one's not going to be different. But at this point, I didn't have that file crazy.php. And maybe that's what introduced the bug. So after I open up my website and test it, because we now have different versions of these files, I could say, well, this is good. So this is git bisect. This is good. And so now it's going to tell me, well, because this one was good, and based on what you told me with what was bad, this commit here with this hash is what introduced your bug. So now if I do a git branch, you'll notice that it says I'm not on any branch. Now the reason for that being, when you check out an actual commit and you replace all the versions with the files in that commit, you're not going to actually stay on this master branch. You're kind of be on this special branch where you're not really anywhere. So in order to get back to my repo and get back to my history, if I go to git checkout master, that's kind of going to put me back to where I was before. So again, this git bisect is not changing the stable version of your project. So even though you're wiping out files and replacing everything, you're not actually losing anything because this was done on this special branch so that everything on master is unaffected. So get smart enough to just delete this kind of sentinel branch for us after our bisect is done. And so also just a reminder, so what git bisect is actually doing is it's checking out individual commits. So let's say I want to take a look at what this commit looks like. So instead of saying git checkout and then a specific file, if I just say git checkout and then an entire commit hash, I'm now at this state, right? But I'm no longer inside of my master branch. So if I say git branch, I'm no longer on master. Again, Git has created this default special branch for me in which I can kind of play around and make commits without affecting my master branch. So now that I've said git checkout a hash, I've literally replaced all of the files with the files as they were in that commit. So if I do a git log, you can see that this is my entire history. Because at this point in my history, I haven't made that branch, and I haven't done anything with that branch yet. So as far as Git's concerned, that doesn't exist. So I've literally stepped back to this point in time, so much so that Git has no idea that I ever made those commits in the first place. So again, if I look at my git ref log, you can actually see all of these checkouts that I did. So nothing is truly irreversible, because I could just switch back to this B7 state in order to get to where I was before. But because Git was smart enough to do this on a branch for me, if I just switch back to my master branch, I'm back to the current state of my project. So if I wanted to actually preserve some of those changes, I could create a new branch, make some commits onto that branch. Then when I switch back to master, I again would have two versions of the file. One representing this commit as it was before, and one representing where it was before I kind of went back in time. Make sense? Nice. So basically the bottom line there is that git bisect is really cool, and you can find bugs in your website really, really quickly with that. But Git provides a lot of different ways of kind of rolling back in time in order to utilize that history. You're not just making commits for no reason. You're making commits that you could really easily roll back to and look at how you did things before. So finally, perhaps the most important or biggest benefit of Git for your collaborative final projects is this focus on distributed development. So you can have two developers at the same time working on your project and each working with the same history. So if I make a commit and then my partner makes a commit, I can do everything with his commit that I could do with my own. So I can roll back to his changes, look at his commit messages, and find out where he messed up all of my hard work. So in order to work with collaborative development, you might want to create something called an SSH key. And so you might have heard of this before. But basically what an SSH key allows you to do is log into a server without using a password. So if you ever had to SSH to cloud.cs50.net, it prompted you for some password. By creating a keygen, it's going to allow you, or by creating an SSH key, it's going to basically allow you to establish, well, I'm Tommy, and I don't need to give you my password. Because you have my key, I must be Tommy. And so what SSH keys will allow you to do is interact with sites like GitHub, which is a really handy site for basically hosting all of your Git projects. So if you haven't already, I would highly recommend creating a GitHub account, and it's going to ask you to set up an SSH key. The reason being, when you interact with this server, you're not going to have to type your password in 100 times. So now let's say that I have my history of commits, and I want to send it off somewhere. And so one place I might want to send it off is GitHub. And I'm going to say, well, GitHub lives on the cloud, some server, and I want to send it not only all of my files, but all of the history of my files. And so to do that, I'm going to use a new command called git push. And this push is going to take an argument that's the URL of where I'm pushing. In this case, this is what GitHub URLs look like. Basically, the username is first, and then the name of the project, and then what branch you want to push. So typing that URL could be really, really annoying. And so you can set up what's called a remote. And so a remote is basically just a shortcut for this URL. So when I say git remote add, I'm going to create a new remote, and I'm calling this origin. And origin basically maps to this URL. So whenever I want to push, or as we'll see, pull or clone, wherever I would have used this URL, I can now just say origin. So instead of git push that big thing master, I can just say git push origin master. So that's one way. So that's if I, as a developer, want to send my files off to a server for the purposes of backing them up or even to deploying your site. So now if I'm another developer who's just wants to start off working, my partner procrastinated a lot and I have all these commits and he hasn't started yet, and he wants to pull down my entire history of commits, and he hasn't created a repo yet. So to do that, he, like you have been running on all of your problem sets, is going to run git clone and then specify the URL of this repo. So what this is going to pull down is not only the current versions of all the files I've been working on, but the entire history as well. So if I already have a repo, if I've already been working on it and making changes, I'm not going to run git clone. I'm instead going to run git pull. And so what this is going to do is effectively take all the changes that have been made since my last pull and merge them into my current version. So I'm not going to pull down everything. I'm just going to pull down all of the changes that were made since the last time I pulled. And so let's say we have two developers here, Alice and Bob. And so Alice is going to start off. She's going to create some new Git repository via git init, and she's going to add files and make changes and eventually establish this commit history. So at some point, she wants to send her files up to a server, whether that be GitHub or the site. And so she's going to say git remote add origin, and then specify her GitHub URL, the URL of her website, and then she's going to push those changes. What that's going to do is going to send that entire history up to the server. So now I'm Bob, and I haven't started developing yet, and I want to get those changes so I can start working. So I'm going to say git clone, and then clone from the same URL that Alice just pushed to. And so that's going to pull down all of my files. And so then now I can add commits and create a history, and then eventually I'm going to want to send those off to the cloud. So when I say git push origin master, it's sending all of Bob's work up to the internet. So now if I'm Alice, I can say git pull origin, and I'm going to pull down all of the changes that Bob just made. So now if you're working with a partner on a project, you don't need to both SSH to the same server or figure out some weird way of both being able to edit the same files. If you just use a Git repository, you can both just push and pull from the same repository and both have the same version of the project that incorporates all of your changes. So now when you're dealing with branches and remotes, when you first clone something, you're not going to pull down all of the branches that exist in that repository, just because there could exist a bunch of branches, and you don't want to pull them all down at once because that would take forever. So if instead of saying git branch, you say git branch-a, where A is for all, you can list all of the branches that currently exist on the server. And so one such branch could be something like origin/test. So in this case, origin is, again, the name of our remote. So we set up that remote called origin. And there exists on the server some branch called test. So now if I'm a developer and I want to get that branch, what I can say is git checkout and then -b for create a new branch. And I want to pull down this branch called test. So that's in the case, we want to back up servers to GitHub. But what if we actually want to use Git to deploy changes to a website? And this is something we do in all of our CS50 software, like the queue or repo, as you've seen. So again, to do that, we're going to want to set up SSH keys again. So in GitHub, we just have this nice interface of just copying and pasting a key into a text box. Where if we're working with our own server, what we want to do is we want to copy our public key So an SSH key has two parts, a private key and a public key. So the public key is, you can just show everyone, it'll be fine. So we want to copy this public key to the server. We want to put it inside of a directory called .ssh, and we want to name it this file authorized_keys. So this file actually contains a list of every SSH key that can access the server. So once we've done that, we add all of the developers' files, all the developers' public keys to this authorized key file. That means that all of the developers working on your project can push and pull and clone from the same repo. So now, on the server, if you want to create some repository that I can actually push to, instead of saying git init, I want to say git init --bear, where this second flag basically says, this is a repository that's not going to actually contain any files. Instead, it's going to be a place where I can push to. So in GitHub, when you create a new repository on GitHub, that's what this is doing. It's just a place where you can send your files. So now, when I say git remote add, instead of specifying that Git URL, I'm going to say something like my name at cloud.cs50.net, and then where that repository is located. So keep in mind that you don't just have to have one remote. And in the case of all of the CS50 apps, we have multiple. So when I could have a remote for my GitHub, where if I say, git push GitHub master, that's going to send it to GitHub. I can have another remote called live. That's like the live site, what users are actually seeing. So when instead of just backing code up to GitHub, if I instead want to send all of my code to my site, so that if I'm a user accessing the site, I'll get the new version, I would say something like git push live master. And so basically, we can have this same history sent to multiple places by creating remotes. Now, a cool feature of Git is these things called hooks. So a Git hook is basically just a script that's going to fire when you do some predetermined action. So every time you commit, Git's going to look for this script called post commit. And if it exists, Git is going to run it. And so the one we're looking at right now is a script called post receive. And so this is a hook that every time that I'm a repo and someone just pushed files to me, I'm going to run this hook called post receive. And so this looks a little bit cryptic right now, but let's just walk through it. So what we really care about is this git checkout. So remember, what git checkout does is going to take all of the files in a given state and replace the repository with those contents. So now I want to, instead of replacing them in that current location, I want to put all those files somewhere. So in the case that I'm deploying files to a website, that somewhere is going to be my public_HTML folder, which you'll remember this is where all of your PHP and your HTML files live in order for the user to access them. So if my repo exists and it's just some folder in my home directory, and I push to that, then every time I make a push, I want to take the public HTML directory and replace it with replace all the files inside of there with the most recent versions inside of the repository. So that's what this git_work_tree is doing. This is saying, I want you to check out into this directory. So not into right here, but instead move all the files into public_HTML. And so you may have noticed as you're developing that doing things like chmod all the PHP files and all the images gets really, really annoying. So what we can do is we can kind of facilitate that process with a hook, where we say every time that you make a push, I want to also run some chmod commands to fix all the permissions. So every time I change a file or add a new file, I don't have to explicitly chmod it. But when I push the file, Git is going to execute this script that fixes all the permissions for me. So hopefully no random 403 errors, because those are kind of annoying. So let's just take a look at how we could do that. So here's my Git repository, remember. Now we have the same log, all these commits. And so now I'm SSH to cloud.cs50.net. So I want to make a new folder. I'm just going to call it repo, and I can really call it, again, whatever I want. So let's go into that repo folder, and I'm going to say git init --bear. And so now I've created an empty Git repository, but instead of being placed in a folder called .git, I've actually just put the contents of that .git folder right here. And so you'll notice that I have this hooks directory. So if I go into hooks, I have all of these kind of sample script files created for me, just so I don't need to remember what each of them are called. So there's our post receive. So let's just create a new one. We're going to call it post receive, no file extension or anything. And so now we're just going to execute that one line. So we're going to say, I want to check out these files into tmacwill public HTML. So that's where I want to check them out, and then here's where I actually check them out. This -f just says, I don't care what was there before. I want you to blow everything out without asking me. So the F is just kind of for force, but I've used it with rm before. And so now we want to make this executable, so we can just mod a plus x post receive. So now this is executable, which means the server can actually execute it. So now let's go back to our original repo. So first, just public HTML. It's currently empty. So now let's go back to our original repo, and let's add some new origin. So git remote add. So we're adding a new remote. We're calling it origin. And the URL is going to be, we're going to say SSH, because remember, I SSH to the cloud. And I've already set up my public keys. So if you look at my .ssh directory, I have this file called authorized keys. And inside of that file, this is what my SSH public key looks like. So I've already just copied my key into this directory, and I've named it this special file name. So back here, so I can SSH correctly. I don't need to provide a password or anything. So this is my username. And then at cloud.cs50.net. And so remember where we just put that repo. It's just in my home directory. So home tmacwill repo. So you notice that it's not inside of my public HTML folder, because I don't want any user of my site to actually be able to access my entire history. So by putting it outside of public_HTML, that means that no one can access my history. So let's just add that remote. And now if we say git push origin master, so there we go. So we just sent all of these files to this special URL. So now let's go back to the cloud and look inside of this repo. So here I am in the cloud now. Now if I SSH repo and do a git log, here's my entire history now on the cloud. So now with the magic of this hook, if I now look into public HTML, there is all of the files that I've just created. So I've just sent from my appliance, basically, sent my entire website up to the cloud with one simple command. I don't have to stay in the cloud to work on my files, and I don't need to worry about copying everything or like making sure that the version on the cloud and the version on my appliance are synced up. By just saying git push, I've sent all of the most recent versions of my file to a server that all of my family and friends can access, which I dare say is quite possibly the coolest part of Git. So any questions on the collaboration bit? All right. Well, in that case, you've actually mastered a lot of really awesome Git tricks to the point where you are a very advanced Git user now. So just moving forward, just some really helpful resources. There are a lot of free books that have been written on Git that kind of expand on some of the topics we hit on today. The last of these pages is the official documentation page. And if there are no more questions, then I thank you for checking out my seminar, and I hope you can commit to using Git on all of your projects.